Okay, I'm back. I'm just going to do some more soldering first because I want to get this out of the way. I need my screwdriver, actually. Stupid little, power thingy. So, whoops, oops, oops, oops. Gotta get that screw in there. Into the heatsink. Yes, this is not going to be fun. I hate it when they're so picky on the size. Let's see. There we go. So, let's begin. So, first thing, of course, lowest level parts first. Get our little bender out here for the parts. Bend all these parts. So, while I'm working on this, I figured out the last of the import problems on CircuitPython, Visual Studio Code, CircuitPython extension, Pylants, and Magic Python. The whole kit and caboodle. So, together with some help from the, what's it called, PIYI listings, I figured out what was kind of going on. Whoops, we don't want to do resistors just yet. So we need to do diodes. Little bandies. Gonna go this way, like so, and another one that way. Oops, I bent that one a little wide. It's okay. No problemento. Who cares? So, and that one goes into here. Bar that way. And one more. This is the full bridge rectifier. Yes. As Electro Boom would say. Gotta get that t-shirt, I think. Okay, and there's another diode somewhere around where? I know there's one more. LED, fuse, resistors. Aha. D3. It's kind of a gimme. Bar that way. Yes. For someone who designs these boards, they put the holes too close together. Okay, so then we have to do resistors. And we have, let's see, two with the green band on them and two with double red. So double reds being 22, or 220 actually, right here. I think I'm going to change the diode a little bit. So let's change this a little bit. We're going to make it like this. So like so. We'll make them vertically challenged diode. There we go. Then we have 5K, 470 ohm. The C2 over there. 10 microfarad over there. The transistor, which we can put in. Lucky it's a small little part. There we go. There we go. 5K1, that's going to be the green because green is 5. Bend the legs a bit. Like so. Like so. And what else we got here? There's a 104 microfarad capacitor up there. And C3 is another 104 right here. Could be picofarads. All I know is it's 104. So let's put the other one up here. Bend the legs a bit. There we go. Okay, so we have a big capacitor, a little capacitor, another big capacitor. So, okay, so I have them on my table here. I have the diode. And of course, since I never, ever, ever remember, so I keep the LED polarity. What was it? Long leg is plus. Yes, yes. One of these days I'll remember what this is. Long legs plus. So, like so. And we have the fusey thingy, which is this. See if we can get that in there. Oops, that didn't work. Whoops, we really bent the leg on that one. We shouldn't be doing that. Let's try this again. Fuse. There we go. So, okay, so we need our arm. And we need some of these guys. So I know I have to hold the LED in place and the fuse in place. Okay, pencil. Tinner tip. If you're wondering, it's this. It's kind of like solder, but it's not solder. It's just tinning material. On all it does has no resin in it. So, lights. Sorry, glasses off because I can't see a damn thing. And let's deal with the transistor. There, one transistor. Then there's this part here. And that part there. That part there. There we go. That one. That one. That one. All these diodes. And that rattly little part right there. Oh, that didn't work well. There we go. So now we got this side. Now we got that little fuse thing. Take the copper off. Then we got that one, and then the LED. And take the copper off. Okay. We need our little trash can. That little plastic is a little big for my trash can. So is this one. We're going to dump those later. Okay. Whoops. I saw that bounce. Well, kind of saw that bounce. Well, no, we don't throw the board away. That would be dumb. So that's just like a power supply. Feed it some voltage, out comes some DC. I got them because, well, I might have to actually change the diodes on here. I don't know 100%. There's a toasty warm they get. I got lots of diodes, so. One more. There we go. That's those ones. Okay. Time for glasses again. Okay, so let's do the next biggest part. And let's see. Let's do the LM. So we have to go and make sure this all fits correctly, like so. Now get our little and glasses off again. Okay, let's do the legs of the transistor first. There we go. Now the pin for the heatsink. This needs a lot. There, copper can go. There we go. Nicely done. Arms, just move over for a sec. I need my glasses again. Let's see, caps. So we got a really big one in the center. Like so. And then we got a medium one. Like so. And then you go with teeny weeny one. Right down the center. Well, we can't even put the big one in yet. Because we can't even get this one in. We better do these two first. Like so. We'll do the big one last. Okay, so okay, here we go. Done. A little clippies to get the leads off. There we go. Now let's get the big one in. Negative, negative. And this one can be soldered right away. Good. Clip this. Clip that. Copper into the center there. Okay, so now we have the green thing, the potentiometer, the clips, and the power switch. So let's do power switch first. Wow, it's having a hard time going in. Let's see, where's my pokey device? There we go. That works. And it popped out on the rear side. So we need to get it back. Oh, that's kind of why. There we go. So when you do switches like this, you kind of need a lot of solder. There we go. Not quite. Just missing some on this side. There we go. Nice. Whoa, doink. Okay, so next one. This guy right here. Ow, 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 ow. That is hot. That is hot. No. Okay. Which side? This side? Oh, yes. Okay, this side. Okay, so it could be in there. Or it could be in there. Well, that's not good. That's crooked. So if we're not doing the two inner ones. Ah, there we go. So let's just put it on our stand so we can see this one better. There we go. There we go. Go around. There we go. Oops, got a kink in my solder. There we go. So, some more clipping. We need to clip the leads on the transistor. And we need to clip the lead on this. Okay. There we go. So now it's with the little greening thing here, which goes over here. Yeah, if you're wondering, this thing's all marked, so I don't really need a circuit diagram for this. It's pretty straightforward. So we want it nice and straight. Yes. Back onto our stand again for a little bit. There we go. Almost done. If you're wondering, yes, they gave me 2 extra resistors. There's no other place on the board to put these. So just put them there. And then we got this one here. Oops, bent leg. Goes right here. It controls the voltage level. In this case, we need our copper again. Since I'll do 2 coppers here. There we go. Like so. Like so. I'll get the middle leg. And here we go. There we go. Take the coppers away. Get the outer legs. And there we go. One board built. Put the little control on, something like this. There we go. There you go. So you would feed it some in, and you would have some out on this side, I think. Yep, in, out, on, off, yada. Oops, don't throw it out there. Throw it in the bin with the other ones. So, of course, we clean up. There's that one that bounced. There's another bag. And I can go like this. So I got some new stuff for the RGB matrix. I think I bumped the camera. There we go. So these things go on a Raspberry Pi. And the idea is those 8 Hub 75 connectors, the 2x8s, go in here. Do I have the bag of them here? Or did I put them away? I think I did. So the idea is there's going to be 3 connectors. I have some parts coming for this side. I have these headers. I bought some of this stuff. This is for the Arduino side. This is a whole bunch of pre-done, just the right size for Arduinos. So, and then I have a whole bunch of this in doubles, but with really long legs. The idea is it sits like a hat on your Raspberry Pi, and you can drive 3 channels of RGB matrices. But we can't start that for a little while until the rest of the parts arrive. I also bought some Raspberry Picos. Yep. These are CircuitPython capable, among other things. So I happen to have, as I said, I solved the problem. So let's kind of look at this, recap it a bit. We need a desktop. Desktop. Boing. Well, that looks like a desktop. Okay, where's my mouse? I know it's around here somewhere. There it is. Okay. So we have 3 places we have to import stuff from in our projects. If we look in here, no, into download for a sec. So if we go into the Adafruit, do I have the Adafruit Circuitpython Raspberry Pi Pico UF2? No, that's not it. Where did I put that directory? I'm pretty sure on this machine it's on work actually. Where did it go? Apparently I don't have a copy over here. So they don't have a copy over here. Let's go get one. We need the CircuitPython library. Library overview. So we need, let me find it on their site. CircuitPython library. So this is the library that you get parts out of to put onto your boards. So we go get the library bundle. And I'm going to do that right now on another screen. And I'll download that there. Just for example, I'll download that one too. And just for double example, I'll download the examples. There we go. As you can see, we're busy downloading. Okay, ls-la. So we have these guys up here, these 3. So all being zip files. Let's see if they're in a subdirectory. The easiest way to do that is just do a test on the thing. Bundle 6. Yes, so unzip. Now we have a directory. So this is the first part. In this lib directory in here are all the libraries there are. You would select out of these libraries and you would put them onto the CircuitPython drive. So I happen to have, I think, 2 CircuitPythons mounted. So let's look at the one that's running the panel. Not that one, this one. And in this lib directory, they asked that on the matrix portal M4 that these are the libraries I need. Now notice all these libraries are MPY files. And you see all this. So that's the first type of import we have to, well, first or second, doesn't really matter. This is one of the import types we have to do. Now, the CircuitPython extension in Visual Studio Code, here, not OBS, sorry, Studio Code. If we go and open our workspace for that thing, I'm going to open the workspace on that CircuitPython. This one here. So when we look at this one here, there's a piece down here, right there. It says choose board. So we need to set our board. Matrix portal M4. In theory, what this is supposed to do is put a pointer basically to all the bindings for various things here. But I have found that that wasn't working properly. So I had to add this. So these stubs represent, I don't know, I just call them like little wrappers that point to the built-in core modules on the board that's in the UF2 file that you end up loading onto the board for that particular board. So, and there's a site on Adafruit. Let's see if I can find it. It shows you all the possible modules per board. So if we, wow, they did a lot of updates. Just today, yesterday, holy moly. They're getting actually ready to run 7, but no, this is not the page I want. I want documentation. Circuit Python library docs. Yeah, here we go. Core modules. So I'm just going to bring it over here. So this page lists all the core modules that you'll find on all the boards. All these guys here. Now what you can do here, go to the module support matrix, find your board. Metro. Oh no, we're too far. Matrix Portal M4 right here. So this particular board that I have driving this panel runs all these core modules. And those bindings files are supposed to expose these to the Python code. In Mu, the editor, it seems to work auto-magically. In Studio, not so magical. There's some issues. So what this stubs is supposed to wrap around that and expose all those to your code. So you can actually see in here, where's that browser again? One of them, for example, let's just look at here. See frame buffer IO right there? This guy right here, frame buffer IO. So when we look at here and we look at code, there's a frame buffer IO right here. To make all this work, all what you're seeing, the tooltip, everything, telling you what it is, to fill in stuff for the frame buffer IO, usual stuff, it has to be able to actually find it. So that's what that path does for the stubs. Now, I also found out that it wasn't perfect. I was finding certain things wasn't working. Yeah. So, for example, this out of port requests right here, this module, wasn't showing up. I don't know why. It just wasn't doing it. There was another one in here. Yeah, display text. That was another one. So what you end up have to do is you go to pi. I think it's pi. The index. And if we go Adafruit circuit Python, and we just search, there's all these standalone versions of this stuff. So what I had to do was find, for example, Adafruit display text. Let's add that on there. See what happens. There. CircuitPython display text. Okay. This gives us this right there. Exactly the same as in our code right there. Okay. Once I knew this, what I ended up doing is taking a copy of this, going to the prompt. Now you can do this as a local user, or you can do this as root. But basically, it would be pip3 install. Actually, paste. These will provide that. And as you see, I've already installed it. And in fact, pip free list, I've installed a whole bunch of them. I went through every one, basically all the core modules and stuff, found the missing ones, and installed them this way. Bitmap fonts, bus device, display text, you get it, all those different ones. Once I did all that, that solved the core modules problem. It also kind of solved the library problem. But the library one's kind of an ongoing thing because I only solve for these particular libraries on these particular board. If I was to switch board to a different board that required different libraries, I would have to go back and find the equivalents and do the installs for them. So I've covered straight import of Pi, which was no effort. I've done the libraries and the MPY files. I cover them. And I've done the core modules via the the stubs files, the MPI files. So now, whenever I bring anything up on this thing, I don't get a squiggly. The reason for the squiggly over here is just I'm not using the import. I mean, I can go like this, basically. Right? Voila. Oh, yes. This guy here, when you start seeing that's PyLint at work. There you go. For some reason, the Pi file has to have one extra blank line at the end of the file. Woo! Yes. But there we go. All the imports fixed. All the stuff good. And in this case, as you can see in the corner of the screen, this is the code I'm currently running on the board. And of course, you probably don't believe me, so let's go like this. RGB pins. No. What we want is our color here. Right? There you go. Different color. Ta-da! Yes. Oh, I slowed the scrolling down because it was it's going lightning fast. Simply with a it's in one of the code blocks here. Display. Oh, what did I do with it? I had a time thing in here once just to slow it down, but it seems to stop doing that. Oh. Well, but you get the idea. So that's that. Now I have another one. So let's go File, Close on this workspace. Now I have another, as you see, two CircuitPythons here. This guy here, right, is the actual Pico. This guy right here above the screen. So I've got it plugged in. I've got the drive. I put the UF2 file on. So it's all ready to go. Now what we want to do is go to code, and I think I'll try a basic way of doing this first. So we're going to open a folder. Not that one. This one. We are going to turn it into a workspace. Let's just have it reload because make it happy again. Um, we are going to change. Sorry, save a workspace here. Save workspace as, and we'll call it Pi Pico. Save. Okay. Now, just like, open the code up. Oh, it's a print hello world. Woo, that's impressive. Not really. I wonder if we can blink a light on here. There is an LED on here. I think there's two actually. There's one right there. And no, one right there. I wonder if we can make that LED blink. So, we don't need this screen. We don't need this screen. And we don't need this screen. And we don't need this screen. And we do need that screen for something else. So, here's our Pico. Blah, blah, blah. Da, 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 da. Let's see. It comes with a PIO state machine system, which is unique and powerful to create custom hardware logic and data processing blocks that run on their own without taking up CPU, for example, NeoPixels. Okay, so what we need here, not from Adafruit, what we need here is, see if there's a blink program. Yeah, that's what we want. Let's see. The built-in LED. Copy the code. Go here. Control V. Control S. What do you know? We just turned on the light. Where is it? There you go. One light. So we could make that blinky. One of the most basic players is managing the digital inputs and outputs. Usual stuff. Down the file, LED value 2. And he turns on. So this guy here. Copy code. This is your classic Arduino blink code program. So let's put it in here. Control V, Control S. Well, we need a delay in here. Let's see. So copy code again. That introduces us to delay. So this is how easy it is to do CircuitPython. There we go. Exactly the same as like a nano or something like that. Oops, I kept moving it out of the way. But there you go. You can see blinky light on off, on off. Exactly as it, but we did it a lot quicker than when we worked on one of these. Although I have to say the nano is smaller. But there you go, classic blink program for, and we haven't even got started on this thing. This thing has so much, and I bought like 5 of them, so I have a whole stack of them. I'm thinking actually of getting some more and putting some long legs, so I have male on the bottom, right here, and female on the top. So depending what I wanted to do and what jumper leads I wanted to plug in, or I want to put on a breadboard or whatever. So, yes. Now, I'm just going to close this off. File, close, workspace. Now, if we go down to here, to platform I/O, and we go down to boards. Picos. Look what we have here. Platform I/O understands the Raspberry Pi Pico. So we could create a project with this. So interesting. So this does it differently. This treats the Pico not like the CircuitPython does with the thing. I think this one is more pure C. So you get the maximum amount of space out of your flash. Whereas the CircuitPython, one of its failings for this one is it occupies quite a bit of the flash space, almost half of slightly over half. So you only get a little under 1 meg of space to work with to store stuff. Whereas this one, I'm pretty sure, lets you do it like these guys, the Arduinos and like Nanos or Unos. You code first and you push the code to it. So yeah, we can go to the home here. We can say a new project, and we'll call this Raspberry Pico. That's not Pico. Pico. Select the board. Pico. Pico. Yeah, so framework. Arduino, use default location. Sure. Finish. So it's going to build us a projects directory. This is just telling us what we can expect. So now we have a project, Raspberry Pico. Now, in this case, file, save workspace as, and we're going to call this RP Pico. There we go. We have a platform I/O with a Pico. We have, get rid of this. The source. We have our main. And there you go. Classical Arduino. So in theory, we should be able to go to, let's have our file export here. No, we don't need it. Yes, no, yes, maybe. Work, Arduino, examples, basic, blink. Now, this particular one, I'm going to unplug it, put it aside, and I'm going to put a brand new one on. And just to make sure that we have it, message. RPI right there, blah, blah, blah. Okay. So let's see what happens. So I'm going to go here and in the blink INO file, there, Control A, Control C, and we turn around and we go here and we go Control V. Now, since we're converting our Arduino to a CPP file, we have to remember, include like so. Now we can check. Oh, I saw some red there. Air 127, SH, ALF 2, UFS not found. Okay. So we're missing a piece here. Huh. Control C, apt install. Do we have that? Oops. I can't spell today. There we go. Yeah, no. INSTAL. So we're missing a component here. See. Linux. So Pico quick tool chain instructions. Let's find out. Oh, boring. Not what I'm doing. We need to build that tool, so we need to figure it out. Releases. Oh, we're missing a chunk. Okay, getting started. Open a new link. Let's see what happened. What do they want? Dun dun dun. Content. Yeah, boring. Quick Pico Star. W get. Okay, let's see. Go back to a user here. CD work. Okay, change mode 755 Pico. Okay, so what else do we need to do? Okay, and Pico. Well, that's working on that. No, we're not doing this on the Raspberry Pi per se. Examples. Okay, see where it's done. It's still working on it. Pico extras, okay. There's our ELF2 whatever tool. I saw it. Ooh, quite a bit of stuff gets done. So far, pretty clean. No utter nasties. Let's see. Flies by at 1,000,000 miles an hour. Do 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 do. Wow, it's building a lot. What is building? I wonder if it's building all the core modules. Because I mean, this thing behaves a lot like the CircuitPython layout does. TCL. VS Code's already installed. Uh-oh. Okay, what happened here? Yeah, we're not on a Pi, of course. No, 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 no. We're not doing ARM. Why would you want me to install ARM? This is stupid. Why would you direct me to do this shit on the Pi when I'm on the not on a Pi? Uh-huh. Did we get enough of it built? Yeah, that's not good. I hope I didn't break this. Let me go and close this for a sec and open it again. Nope, it's okay. Still running. Ah, we got enough of it to make it work. Well, maybe not. Upload error one failed. Target upload terminated. Blah blah blah. What did you complain about? Okay. B message. Let me. Oh boy. I think we just blew up the matrix portal. Ha ha ha. Oh, that's not good. Nope. Still working. Okay. Let's replug this in again. So it's showing up as a storage device. And this expecting to do uploading build Pico firmware.elf. Gonna have to do some reading on this. I can run it like a CircuitPython, but I cannot seem to run it like a Pi. No, Arduino framework. Well, I will look into this. This requires some thought, thinking. So for the moment, file, close workspace. And put this back over on the other monitor for a sec. And we don't need this. So, yeah, so, I mean, I'm still waiting for some more parts. I did get in the more higher end matrices. So, you check this out. Let's go turn the desktop off for a sec. So, we have this now. This is 64, 128. And I have two of them. So, I have two of these. And I have a 64 by 64. You know, it's funny. This guy here from Adafruit look like it's from the same company, actually. Laid out identically. In fact, the labeling is practically identical. Which is a good thing, because that means then when I hook it up to the matrix, yeah, it feels like I'm talking the movie here. It should work just fine. I've got some more power supplies for the panels. These guys here. So these are 5 volts, 12 amp power supplies. More than enough to power these panels. Oh, and it blew a monitor up. Yeah. To get another one. So, but that's about it. I mean, I got some other stuff coming from Adafruit to fill in some gaps and some stuff here. And we'll find out. So I think I'll end it kind of early. Bye.